All right, so let's see about some quick reminders. You guys know how to find the notes. Okay, if you got any trouble finding the notes, please let me know. It's crucial, almost updated on a daily basis. Your lab number 0 is supposed to be done. I mean, both the part 1 and part 2. That's really what the programming test number 0 next Wednesday, not this Wednesday, but next Wednesday is going to cover. So please make sure to read the guide on programming test 0. It really outlines explicitly and as complete as possible about the expectation, formats, and grading scheme, etc. Things will be followed consistently for all the subsequent programming tests. So please read it through, and it'll be worth your time. Lab number 1 is released as well. So it's going to be due, I believe, next Tuesday, right? So I believe. So please also try to complete it as, struggle through the concept. You can reach out to TA or myself. The TAs will be there after the mock-up test today. So you can definitely ask questions about Lab 1. That one is going to be covered in the next programming test, which will be programming test 1. I'll speak more about it a little bit later. Okay. So for today, the lab session, so I believe you guys' session will start at 2:30, right? So please come in time to Williams Small Center, and then I'll guide you through about a mock-up test. I will be there, at least for the beginning part, so I'll definitely let you know what's to be expected. And then after the enroll session, after the mock-up session, there will be Q&A. I'll try to stay there if possible. If not, the TAs will be there for sure, so you can definitely ask questions. Okay, so that's kind of the plan. Guys, any question about the course in general? So everybody kind of know what's to be expected, right? So the semester calendar is really the PDF to really print out or save somewhere handy for you to remind yourself what's going to happen in the course. We do have some steady evaluation on your learning, so please make sure you follow, keep up to the pace. All right, so let's do some recap. All right. So last time, we actually spoke about something called variable shadowing, okay? So it is to say, so you basically think about you got 3 versions of the constructor that we talk about, right? Version number 1, if we choose the new weights and new heights, so we don't have any name clashes with the attribute names. In that case, you do not need to use the this dot notation to really break through the variable shadowing. Variable shadowing only occur when you have a name clash like this, like a weight here as a parameter name, and also the weight here as an attribute name. That only happens when you got clashes between the parameter name and also the attribute name. So that's why we got version 2. In version 2, if you got weight here and height over here, in that way, if you only say weight over here, it's still referring to the parameter. That means we are only changing the parameter, not the attribute. So that's a wrong version. So the final version we have, version number 3, is really to have this keyword right here. So if you say this dot weights, so this weight here, even though it clashes with the name of the parameter, but that's okay, because this dot makes sure you can break through the variable shadow and refer to the attributes right here. So we got 3 versions over here. So please make sure you understand about why each version will work or not work. It's very important. I might test you on that later in the test. And whether you want to choose version number 1 or version number 3 using this keyword is completely up to you. So there's really no right or wrong. But I can tell you that it's just more common for Java developer to use version number 3 by using this keyword. So you don't really have to choose unique name for the parameters. All right, but I'll leave the choice to you. For this course, I'm not too worried about if you always stick to version number 1, as long as you know version number 3 can also work, and also version number 2 doesn't work. Okay, so really study the 3 versions. That's really the best way to really review this topic here about variable shadowing. And we talked about tracing OO code. So we did a little bit of tracing last time. We'll definitely do much more throughout the course today as well. We're going to see how we can actually visualize array and also objects all together. So that will be the first half for today. I'll try to be as thorough as I can. But of course, if you struggle with any concept about the tracing I'm going to do, always interrupt me, right? I think today is going to be very important. So we'll talk about how you can visualize objects. You got a box, meaning that you got some location in the memory that's allocated just for this type of objects. So for the object, you got selected list of attributes that you're interested in tracing. You don't have to include all the attributes, only the selected ones that you actually interested in. And we got instance-specific attribute values right here. And then we got some reference variable, and then the arrow here tells you the following. The reference variable stores the address of this particular object. What you should really know is this reference variable here does not store any of the attribute values. you only store the address of the objects, and the object itself contains the attribute values. So in some way, the storage here is more like an indirect. You only store the address where you can look up in the memory to find out the corresponding attribute values. Right? That's a very important concept to grasp. Okay? And then we talk about how to trace using this notation here. Right? We got two boxes over here. So whenever we got, for example, equals equals right here, right? When we say Jim equals equals Jonathan, there are two ways to interpret this comparison here. Either you can think about whether Jim and Jonathan store the same address value. That's one way to think of it. Another way to think of it is, do Jim and Jonathan point to the same objects? So Jim points to this object here, and Jonathan points to this object here. They are not the same objects. So that's why this equal here should be false. Right? So there are two ways for you to interpret about the equality comparison. Okay? So when we talk about the equals method a little bit later, well, possibly in a week or two time, we're gonna study the difference between comparing address equal versus contents equal for the objects. That's something you should know as well. We'll get there. Right, so we also talk about how you can use the context object here, Jim and Jonathan. You can see they can correspondingly replace the this keyword in the method call. Right? So that's how we actually did the tracing. So that's also very important whenever you want to trace the method call. Maybe you're calling the same method, but maybe the context object is different every time you try to call the same method. So you have to see the effects. Accordingly, you have to do the replacement of the context objects for every occurrence of this, like what we did last time. Right? You can also review how I did it last time as well. I believe in your tutorial video, I also show it. We okay with tracing? The basic one, right? About method call. And then we get onto something called reference aliasing, right? So we first of all talk about this important variable assignment for the primitive value, okay? So when we say int j, we declare j to be a box right here. And we say j is going to store whatever that is stored in I. In this case, it would be 3, right? So we'll put it another way. We are copying whatever that is stored in I into j. In that case, copy 3. And when you talk about reference variable assignments, we're really doing the same thing, except rather than copying simple value like a 3, we're copying addresses of the objects. That's what we're doing. Right? So let's now just review this line over here. Right? When I say point P2, I basically declare P2 right here. And I say P2 is assigned the value that is stored in P1. What does that mean? That means I'm copying the address that is stored in P1 and store that into P2. Effectively, after this variable assignments, P1 and P2 should point to the same objects. All right? So that's something you want to note, right? So after doing this variable assignments, P2 is going to point to wherever P1 is pointing to, right? So that's a variable assignments, right? That's what we said last time. This kind of variable assignments may appear multiple times in your in your Java code that you're given to really do the tracing. Especially what we're going to do today, you can see that we do this kind of variable assignment for every iteration to really update the corresponding index in the array. So that's something we'll see today. All right, so we started with some warm-up exercise for you last time. So the main thing really to review is about how you can visualize about the array, right? We talk about numbers 1, numbers 2. You got two possible ways to really initialize the array. Either you can simply use a curly brackets notation here, where the number of elements you list inside basically specify the structure of the array you're creating. So in this case, you got 3 elements, so that's why you got indices 0, 1, and 2. Another way to do it is to, first of all, create a new array objects right here, like using the new keyword. And then here, we actually got the array size. In this case, we're saying the new array, numbers 2, should be equally long as numbers 1.length, which is 3. So that's why we first of all created this array here. But before we even executed the loop, we actually have the default values for every element here. So that would just be 0, 0, and 0. And then when we execute between iterations, we gradually update the value to 1, and then to 2, and then to 3. Right? That's what we did last time. So whenever you're trying to trace a for loop or while loop, I would suggest always ask yourself first 2 questions. Number one, how many iterations do we have in total? Figure out the number. Number two, what's going to be the pattern of change for the loop counter? In this case, the pattern of change will be I from 0 to 1, and then 1 to 2, and then when it changes from 2 to 3, we know that it's going to make this Boolean condition here in the middle false. So we don't go for any further iteration. Right? So these are the two basic questions you want to ask yourself first before you even start tracing. Right? It's going to be very helpful. Of course, sometimes, in general, you may have more than one loop counter. Well, maybe the condition that's in the middle might be more complicated, might be using some conjunction or disjunction, like n%, or vertical bar. Okay? Any question about this exercise here? We're good? Okay. So let's now do that more advanced exercise together. All right? So if you haven't, please feel free to grab a piece of paper and get your pen and pencil ready, and then we'll do it together. Okay? So let me present a little bit of the slides, and then I will let you guys do something very quickly. Okay? So it will be slide number 52. Okay? So let's have a very quick overview. Oh, actually, before that, how about we just visualize something very quickly? Okay, maybe let's do it this way. Let me just have a very quick overview about what the code is about, and then we'll do line by line. To begin with, we create several objects of type person. And then we create one array over here using that curly brackets notation. And then just notice that now every element in the array is no longer just integer, but rather they store the address of some person objects. So that's something you have to visualize accurately. That's something I will show to you. And then we try to create another array called persons2. And this time we say only of certain length. So that means every element in the array is going to keep the default value. Now, is the default value going to be 0 or something else? Right? That's something you want to think about as well. And then we run a very similar loop over here, right? The pattern is going to be very similar, okay? But I'm going to trace again. So we have this loop here. Line number 8 is really important here. So now we are basically doing some variable assignments. We are modifying, on the left-hand side, some location on the persons2 array at index I, depending on what I is in the current iteration. And the value we are going to store into persons2i will be whatever value we can get from persons1 at position I. Right? Copy that value there and put it inside the persons2 array. So we're basically copying addresses, and that's something we already talked about on Monday. Okay, I'll also talk about it. And then after that, we try to call some mutator, set age. So here we're assuming that we got two attributes for the person class. We got name and the age. So that's our assumption. Okay. And then line number 10 and so on. So we actually try to just call some accessor method and etc. All right. And then we also try to do some further variable assignments right here. Okay. That's something we'll try to trace line by line. Question.
Just for persons2i with persons1i. So when we copy references inside an array.
I'll talk about. Don't worry. Once we Huh?
We're not recreating a new person.
The short answer is no. We are not. Yeah. So whenever you're doing variable assignments without a new keyword, you're not really creating new objects. Yeah. Mm-hmm. All right. So let's, okay, we just want to give you some very quick overview. But why don't we try from the beginning? Okay, step number 1. Can you draw the diagram to reflect after executing from line number 1 to line number 4? Okay, I'll give you one moment and try it. Just for this one here. I'll draw on my iPad as well, but we can compare. Okay, try this one. And again, the assumption is every person objects, the attributes we're interested are just the name and the age. Okay, just one more moment. I'm almost done. Okay, one more moment. So this will be a very nice way for you to also try to kind of get yourself familiar about how fast you should really draw each ingredient of the diagram. Well, you really want to practice as much as you can. You don't want to just practice for the very first time during the test. It's not going to be very efficient. All right, let's now compare. Okay, you should get something like this. Okay, so we are talking about basically these four lines: 1, 2, 3, and 4. So we got 4 reference variables: Alan, Mark, Tom, and Jim. Alan, Mark, Tom, and Jim. Each one of them is going to stores the address of certain objects, right? 1, 2, 3, and 4. And for each one of them, we got the name accordingly, right? You can see, for example, Alan here, Mark here. And what about the age? So in this case, implicitly, we're assuming that since the parameter here does not really take any age number, so I presume it's going to be a default value just for now. Of course, in the real test, I'll make it even more explicit, but this is just an exercise. Okay? So that's why you see 0, 0, 0, 0 over here. Any question just about this first phase? So this one here, nothing new, really, right? That's basically what we did last time about visualizing object creation. And let's now take a look at this line right here, all right? And this line here, I would like to dive a little bit deeper, which I didn't really quite say on Monday, okay? That will also help you understand. So this one here, let me just isolate it and put it elsewhere, okay? Just this line. Before I write down anything, this is how you can understand how this one is going to be done. We are basically creating a person's we are basically creating an array of length 1, 2, and 3. This will be index 0, index 1, index 2. And then at each index is going to store whatever that is stored in the corresponding reference variable. So we are basically copying address already. So think about we are copying the address that's stored in Alan into index 0, copying the address stored in Mark into index 1, and etc. That's what we are doing. Okay? And then persons 1 eventually is going to point to the beginning of the array. That's what we're going to do. All right? So what I will do is I'm going to rewrite this single line here into something that's kind of equivalent, which you can also do. All right? So I'll put it here. All right? Star. It is talking about, first of all, we know that the array is going to be of length 1, 2, and 3. So we got person array, and persons 1, I'll just say P1, just for short, okay? Or PS1. Persons 1 will be new, and then person array. And in this case, it's going to be 3. Okay, let me move that a little bit to here. Oh, sorry. Okay, sorry, bear with me. So we have the first one there. Let me just move that. Oh, okay, the first one. So that one there, what does it do? What that does is it's going to have the PS1 pointing to the beginning of an array of length 3. 0, 1, and 2. And in the beginning, every slot over here is going to store no address, right? Every element is supposed to store the address of a person objects. So the default value should be null. Right? In the beginning, it should be just null. And then we're going to do index 0, index 1, and index 2. So this will be 0, 1, and 2. It will be as if we say persons 1 at index 0 is assigned to Alan, followed by PS2 index 1 will be Mark, corresponding to right here. And finally, PS1 index 2. I'll put it here. So PS2 at index 2 will be Tom. this single line here is equivalent to 1, 2, 3, and 4. Question? Oh, I agree. Thank you so much. I appreciate that. Okay. Maybe the best way for me to fix this. Okay, let me just rewrite it. Yeah, guys, so please do feel free to correct me, just in case I got it wrong. So PS1 at index 1 will be Mark. And also PS1 at index 2 should be Tom. Right, that should be the correct way, okay? And of course, the similar pattern also applies to the primitive array. Let's now analyze this, right? Let's see how we can trace this one here. This one is already done, so that's exactly what we got here, null value. What about this one here? This one's saying we are modifying persons1 at index 0. We're modifying just this slot right here. The way to modify it is to copy the address that is stored in Allen. Allen stores the address of this object right here. If you copy the address into this index, which is right here, right? What does that mean? That means after the assignments, this and this, they will store the same address. Diagrammatically, you'll just let this one, rather than pointing to null, it's going to point to wherever Allen is pointing to. Everybody following? Okay. Let me repeat. How about that? Okay, just in case. The way to interpret this line is like this. We are copying whatever address that is stored in Allen. Allen stores the address of this object right here. We're copying that address and store that into index 0 of the PS1 array. Index 0 is over here. So copying the address of this object into this slot right here. Diagrammatically, what's going to happen is, after the assignments, this slot and Allen variable store the same address. So we're going to let this slot here, rather than pointing to null, is going to point to wherever Allen is pointing to. All right? Think about that kind of pattern there. So rather than pointing to null, it's now going to point to right here. And similarly, for index 1 in the same array, it's going to point to wherever Mark is pointing to, right? You can see Mark is pointing to this object here. So rather than here, it's now pointing to right here. And finally, for this assignment here, PS1 at index 2, rather than storing null, it's going to point to wherever Tom is pointing to, right here. So now we do have aliasing. Okay, I'll give you one example here. Let's say for PS1 at index 1, it is pointing to this object here. At the same time, Mark is also pointing to the same objects. You can see there are two incoming arrows into the objects. So you know there's more than one name or more than one variables storing the address of the same objects. So that's how we got reference aliasing. Okay? Okay, so all the points are important, right? All right, so that's just this single line. Any question about this one here before I move on? All good? Okay. All right, let's now move on to this one here. Okay, so this one here is actually not challenging anymore because this one here is pretty much like the first line right here, right? So we're just going to get default values. All we know is persons1, the length will be just 3, right? You can see 1, 2, 3. So the length should be 3. So what we do is we're going to create. Let me color this one here, okay, like that. So what we have is we got PS2. So we got PS2, persons2, pointing to the beginning of an array, also of length 3, index 0, 1, and 2. And in the beginning, everything, every slot, every element is simply just null. Right? Just after executing this line. Of course, we're going to modify the contents of PS2 later in the loop. That's what we're going to do. Okay. Let's now execute the for loop in a very similar way as we did on Monday. Okay, let me just highlight this one here, and this one here. I'll put it aside. So let's say this one here is star, star. Okay, I'll put star, star over here. And the way to trace it, we kind of went through that already on Monday, so I don't need to repeat 100% detail. We're going to look at how the loop counter I is going to change. We know that only is going to change 0, 1, and 2, but not 3. Okay. So I value is going to be 0, 1, and 2, right, for the different iterations. And let's now try to look at each line, each iteration. Iteration 1. What we get is we're going to get PS2 at index I, which is 0, is assigned PS1 at index 0. All right? I'll pause for one moment. I want you to look at this variable assignment here and think about what's going to be the consequence of doing that. And then how exactly are we going to modify the diagram accordingly to finish executing this line. Okay, just pause for one moment. Anybody want to give it a try? Just tell me how I should change the diagram, first of all, before I explain that in detail. How should I modify? Anyone? Yeah, please.
So PS2 at 0
Uh-huh.
would be pointing to the same place that PS1 at 0 points to.
Awesome. Like that, right? Perfect. Thank you so much. Okay, let me just repeat what your fellow student just said, which is perfect. Okay. First of all, we know that we are modifying PS2 at index 0. So PS2 at index 0 is this slot here. We are modifying this slot right here. And then it should be modified to the value that is currently stored in PS1 0. So if you go on PS1 at index 0, it's pointing to this object here, right? So we're storing the address of this object into here. Diagrammatically, after this is just going to point to the objects. So after this, PS1, sorry, let me say it again. PS2 at index 0 is going to point to wherever PS1 0 is pointing to. Okay. So we're going to do just this. It's going to point to right here. Okay. Are we okay with this? So guys, if you don't really feel exactly comfortable about the logic or flow here, it's okay to speak up, right? Because you do rely on this kind of tracing a lot in this course, all right? Or maybe drop out by office hour if you feel a little bit shy to speak up in the class. That's okay. I do have office hour today, 6 p.m. Okay, speak to me. All right, iteration 2. So we got right here. So we got PS2 at index 1 and PS1 at index 1, right? Which is modifying the value here. So rather than 0, it's now 1. So PS2 at index 1 is going to point to wherever PS1 1. PS1 1 is pointing to this object. So change this way. Okay. All right, finally, we got the third iteration. So PS2 at index 2 is assigned PS1 at index 2. PS22 right here. Sorry. PS22 right here is going to point to wherever PS1 2. PS1 2 is pointing to this object right here, tongue. So it's going to point here. Okay. And something I didn't quite do, but I suggest you also do. You want to make sure you get rid of this null here, right? Just to say it's no longer being null. Okay. Just be careful with your diagram. Otherwise, it might get confused. Okay. All right, so after the loop here, we basically got this kind of setup, right? We got an array here, we got another array here, and each individual element is not null. They point to some objects. They store the address of some objects. And just notice that Jim has not been stored anywhere just yet, which is okay, right? We don't need to just yet. Let's now try to do more. Next one. What about this line here? Persons 1 at index 0. Persons 1 at index 0 is basically pointing to this object here for Alan. We want to set its age to be 70, right? So we assume we actually got a corresponding mutator method to set the age. So now, rather than 0, it's going to be 70. All right? So now we will be able to answer the question quite easily. Let's see. What will be Jim.getAge right now? 0, yeah. Jim.getH, 0. What about Alan.getH? 17, yeah, good, yeah. Not 0 anymore, right? As long as you trace that properly. Thank you. Okay, finally, what about persons 2, 0, getH? Person 2, yeah. At index 0, which points to this object here, and 70, right? Awesome. Right? So far, so good. And let's do a little bit more manipulation, so we just see a little bit more. Let's say we try to execute another line here. How about this one here? Let's say persons 1, 0 is assigned to Jim. So we are modifying persons 1 at index 0. So we are modifying this slot right here. And then we say that it should be pointing to wherever Jim is pointing to. Right? That's what we're saying. So that means it's not going to point to Alan object anymore. Instead, it is going to point to the Jim object right here. All right? After this, we say persons 1 at index 0 set the H to be 75. So now persons 1 at index 0. So persons 1 at index 0. Persons 1 at index 0. It has been redirected to the Jim objects. We want to modify the H to be 75. So modify that to 75. Like that. All right? And let's answer the question again. Jim.getH. What is that? Used to be 0. Now should be 75, right? Alan.getH. Alan.getH remain 70 as before. And then finally, persons 2 at index 0.getH used to be 70. Is it still 70? Yeah. Let's try. Okay, maybe. So let's say PS2, index 0 is pointing to still the same object. We haven't redirected that yet, but I might actually do that maybe in the test question. So you just gotta trace that one more line, right? So persons 2 at index 0 is still pointing to Alan, so it's still 70. Awesome. So that's a complete tracing. Okay. Do you expect this will be more or less like a something I kind of definitely expect you to be very proficient at, tracing. So I would say, take this one here, print out the exercise. You do have the fresh copy on the lecture site and practice. Okay? I would say when you try this out yourself, if there's at any point you kind of find struggling about how to really change the diagram according to the line, that's the point to maybe talk to me or talk to the TA. They might be able to help you too. All right. Any questions before I move on? Yes, please. Is it, okay, good question. Is it a good practice to have aliasing, basically, having multiple variables storing the same address? Yes. Because as we'll see for OOP, the main thing is about sometimes, maybe for the same objects, right? You don't really have to make a fresh copy to waste the memory to make it being manipulated. So sometimes it will be sufficient if you can have two variables sharing the same objects. In that case, whenever you modify the object using one variable, it will be visible to all the other variables, pointing to the same objects. It's definitely recommended. Of course, you got to decide which one to go. Okay? So later on, we're going to cover something called aggregation versus composition. That's when you will see. You have to draw some balance as a programmer to see which one you want to use. Yeah. Any other questions about this one? Yes.
So person 20 had the address of person 10. So why didn't it update it to Jim when we called it again?
Okay, let's be precise. Which line are you talking about?
Basically the last line.
This one here?
Yes, the last line.
Mm-hmm.
So person 2, I thought the person 20 had the address of person 10. So why didn't it update it to Jim instead of Alan for the last?
I see what you mean. So we were okay. Let me just try to see this. Okay, this line here, let's talk about how we executed this line. Okay, before this line was executed, we knew that persons 1 at index 0 and persons 2 at index 0 point to the same objects, right? Good. Okay. So when we actually try to do this variable assignment, think about what we're changing. We're only changing persons1 index 0. We are basically saying persons1 and index 0 here is supposed to store some address. We're going to change whatever address it is storing. But we are not really changing this one here. It's going to be untouched.
Okay.
So when we actually say changing this one here, so that's why we only try to copy the address of Jin into this slot only. So that's why when we modify the diagram, we only say rather than pointing to here, it points to here. But we don't at the same time to say this one here also got to point to Jin. No. I'm glad you asked. Good question. Yeah. All right, so if no question, I want to do another page just to show you something. This is more like also a very insightful question asked by your fellow student from last year. I want to mention to you as well. So this one here really shows to you if you somehow want to copy array, right? You can basically create an array and then somehow use some for loop, to actually gradually assign each individual slot to the right value. That's definitely one way to go. Another way to go, which can save you some time, but there's no silver bullet. It really depends on which one you might want to do. Okay, I'll show you another one. How to copy array. Okay, I'll just do this one here. Okay. So let me call this one here copying arrays. All right, I'm going to show you several lines, but again, you can also try on Eclipse and use a breakpoint debugger to really verify what I'm saying here. Again, let's now have PS1 and PS2. Let's say we got person array. Let's say we got PS1, and also we got person array, and also PS2. Let's say I just declare them without actually initializing them to something, let's say, okay? And I would say upon completing these two lines, let me call that timing number 1, right? I'm going to show you a table about how things are going to change, okay? So let me draw the table here. There'll be several timings I want to show to you. And I want to compare several expressions. I want to compare number 1, whether or not PS1 is null, true or false. And also PS2, whether or not it is null, also true or false. And whether or not PS1 and PS2 have the same address. All right? Now, timing number 1. After that, right? What should be the value for each expression here? So let's now try to just visualize it right away, okay? So you can think about PS1 and PS2. Each one of them is supposed to point to the beginning of some array objects. But at this point, we haven't initialized the array just yet. So that means PS1 and PS2 should point to no, nothing. All right, no array just yet. All right, so this will be true, and because both of them are null, this will also be true. This is important actually because you ought to know when you only declare a reference variable that's an array, when you haven't initialized that just yet, it's just going to store null in the variable, just like a default value. Okay? And then let's say after this one here, we try to do, let's say this line. Let's say PS1 is assigned to some new array, I'll just put dot, 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 the details can be omitted, right? That's something we spoke about in the previous example. And then PS2 will be some new array. Of course, you can also add the code to really assign to individual contents of the array, but I'm going to omit that as well, okay? Let's say this is timing number 2. So after executing another these two lines, we got 2 right here, right? So now we want to figure out what's going to be the expression right here, right? What's going to be this, this, and this, all right? Since we got a new keywords, so we know that PS1 and PS2, no longer, they are null. Agree? Just some pointing to some array. And also, are they the same address anymore? Not really, because we got two distinct new keywords, right? Two different objects, right? So the way to visualize this is like this. So what we're doing is PS1, rather than storing null, is basically going to store some array of certain length. And also PS2, rather than pointing to null, is going to point to some array right here. Okay, like that. Just some array. I'm just not specifying exactly how long or how it would look like. Okay, so that would mean, so PS1 is null, is false. PS2, null, also false. Also, they have the same address, or they point to the same array objects, also false. So far so good? All right. Let's now talk about copying, all right? Let's say if I want to somehow make PS2 look just like PS1, the way we talked about earlier was we can simply run this particular loop and make sure we copy PS2 individual elements into exactly the value that correspond to what's in PS1. That's what we did one by one, right? That's definitely one way to go, okay? But there's another way to go, but I will give you a little bit of intuition about, there's no right or wrong, but let's talk about it first. So let me put you another line. I say PS2 is assigned PS1. Okay, just single line. This one here magically will do some copying. It would. Number 3. What we're doing is copy whatever that is stored in PS1 and store that into PS2. That means PS1 currently is pointing to the beginning of this array. It's not going to point there anymore. Instead, it is going to point, oh, sorry, I said the opposite. I apologize. Let me say it again. So PS2 currently is pointing to this array. And we're going to modify that, right? Rather than pointing to here, it's going to point to wherever PS1 is actually pointing to. That's the right way to go. So please be careful, okay? So what we do is, so PS2, rather than pointing to over here, it is going to point to this particular array, all right? So in this case, PS1 and PS2, they share the same array. In that way, if you say PS1 at index 0, this element here. So PS1 at index 0 and PS2 at index 0, they are the same contents, right? So we got aliasing just at the array level, right? So this is creating alias at the array level. Okay, let's answer this question right here, right? So after executing this single line, right? This single line right here. So PS1, not null. PS1 is pointing to this, it's not null. PS2 also is not null. However, they are both pointing to the same objects, so the addresses should be the same, right? Okay, it is not null. It is also not null, but they point to the same objects right here. Right? This kind of copying here will only be chosen if, of course, it's very efficient. All you do is just copying the address from one into another. But the consequence is, whenever you modify, let's say if I modify PS2 at index 0, if I modify this particular content right here, it's going to impact PS1 at the same time because they point to the same array. If you're willing to take that consequence, you should go with this one. It's more efficient. All right? That one I wouldn't write down, so please take that notes, right? Let me say it once more. This copying here, very efficient. You're only copying from one address into another. However, you should be aware of the following consequence. Since now PS1 and PS2, they are pointing to the same array. If you try to modify PS2 at index 0, in that way, you're modifying PS1 at index 0 at the same time. If that's kind of the consequence you're willing to take, go with it. All right. Finally, we can say PS1 is assigned to null, final one. Okay, let me call that 4. So this one here is saying, so PS1, rather than pointing to this array over here, is actually going back to null. Or you can also try, you can point to another array if you want to, right? All right, so after this, it'll be number 4. So what we got is PS1 right here is actually null. True. And PS2 is not null, right? Because it's actually still pointing to this array, not null. And also, are they the same address? PS1 is null. PS2 is pointing to something that's not null. Null, of course, is not equal to not null, right? So this will be false. All right, so study this extra example very carefully, right? It does show you about different timings of doing the variable assignments. And to really draw the diagram appropriately and accurately is the way to really see how to answer the questions, okay? If you still got struggle, take a look at exactly where you might be struggling. You can ask me maybe a little bit later, okay? Let me say one more thing, and then we'll take a short break, okay? Just one more thing, please. All right, so let me just go back here, right? This is pretty much about the, after the for loop of that previous example, that's the diagram we have, right? I just want to emphasize one more thing. We talk about aliases, right? I just want to do one exercise for you. We can say aliases or alias path, because the name of some objects can be some expression, could be a single variable, or could be some array indexing notation, but we'll see, okay? So now here's a question. How many names or how many expressions really denote the same Allen objects? So the Allen object is really right here, right? Let me just put it here. How many expressions can we identify that's going to store the same address? How many, first of all? How many? According to the diagram. Yeah, go ahead. 3? Yeah, that's right. Okay, how exactly do we tell? Assuming that you draw the diagram correctly, all you got to do is just check to see how many incoming arrows you have. That's about how many expressions. All right, so you got this one here, you got this one over here, also you got this one over here. So these are the 3. Okay, so I'm going to write it down. So this one here is Allen. And this one right here is persons2 at index 0. And this one over here is persons1 at index 0. So these are what we call also alias path. So 1, 2, and 3, if you check their addresses, they'll be exactly the same because they point to the same objects, right? So that's a quick exercise I want to do. 1, 2, and 3. As long as there are more than 1, we can definitely say we got reference aliasing. Usually, if there's only one variable storing the objects, we don't say there's alias, just one single name. But if there's more than 1 names, you would say aliases. All right, questions? Yes?
So basically, if you copy an array from the previous method, the array only changes if we change individual values, but it doesn't change if we change the whole array to the method.
Say it again, please.
So basically, you said like if we change PS2 0, right? It's also going to change PS1. But if we make the whole of PS1 null, it doesn't change PS2 because we're not changing individual.
That's correct. Let me repeat it. Okay. So let's say this. So let's say at this point, let's say in the earlier point, so PS1 and PS2, they point to the same array at this point. Okay. So when we say we want to modify PS1 to be null, so we're only changing this particular variable here. We're only changing what it is stored as an address. So we don't really modify the array that's being pointed to. So these are 2 different things, right? So in this case, okay, PS1 pointing to here, PS2 pointing to here. When I say PS1 equals null, what I'm saying PS1 is null, rather than storing the beginning address of the array, it's going to store just null. So you don't really modify PS2 at the same time. You don't. You want to think about what exactly are you changing. Yeah. All right, good. So guys, why don't we take a very short break, get your iClicker ready, and then we'll take attendance first. All right, so let's now talk about another topic, which is also very important. Strictly speaking, it's not exactly OOP, but it's a very nice way for you to have something that's global for you to actually use. That's really the essence for static variable. But before we talk about even static variable, let's think about what if we don't have static variable? What kind of trouble is it going to give us, right? Let's have some motivation first, right? So what I'm talking about is actually slide number 75 right here. Okay, but I'm going to dive directly into the example, but I should also go over the slide as well. So I think today we'll only be able to talk about maybe the motivating example, understand why it wouldn't work without something global. Number one. And number two, I'm going to walk over with you some code example using static versus non-static. So if you look at the lecture site, I already posted the code right there. So if you see the lecture site, you can see the under the codes right here. Oh, sorry, not here. Right here, under the codes, you can see static versus non-static variable. So that's the example I'm going to present today, right? So you can import it to your Eclipse and play with it. That's really another way to really get yourself familiar with the static variable. Okay. So just to say, today will be the last lecture for this week. So for next week, Monday, I should be able to finish everything about OOP review. But you want to make sure you actually study ahead for there's some about 2 or 3 remaining topics that we haven't really covered just yet. I'll only do that on Monday. So please make sure you actually study them. They will be covered actually in the programming test number 0 next Wednesday. So you got to make sure to study ahead. All right. So these are the basic stuff, but I really want to cover them, but you don't want to wait for me. Okay, let's talk about some motivating example for why we might need something global using static. Okay, let's say we have a class called account right here, and then for the account we have something called ID. Okay, so every account has an ID, right? And then we want the ID to be unique between every account. So we do have some requirements. So the goal is IDs among account objects should be unique. There should be no duplicates. There should be no account objects with the same ID, which makes sense. Are unique. Okay, that's our goal. Let's see how we make this happen at the moment, right? Also, we got owner, okay? And we got some accessor, which is going to return the ID, right, to see what the ID value is. And for now, we just assume ID is simply integer. It could be a string in general. That's something we'll see a little bit later, okay? And we got a constructor here. And notice one thing here right away. For you as a user, if you want to create an account object, you call the constructor. Let's say that's the only constructor we have for the account class. You have to pass explicitly an argument for this ID parameter, all right? Let me write it down right away. So this ID here, right? This one here. So this is some explicit parameter. And whatever value we pass as an ID when we create another new account object, presumably the ID here should not really cause any duplicates among the existing IDs. Presumably should not clash with the existing IDs. Let's say, for example, let's say we already got 10 accounts with ID 1, 2, 3, 4, 5 all the way to 10. Now you want to create another account. The ID shouldn't be any of the value between 1 and 10. It should be, for example, 11, right? So that's something you want to make sure. However, this kind of style of design is going to put some burden on the user of your account. So that's why it's not ideal. I'll illustrate to you. And of course, you also need to pass the owner, right? And then you just have some very, you can see we're using this, right? To break through variable shadowing, right? We are using that right away. Let's say we got account tester right here. So we are trying to create 2 account objects right here, okay? And then you can see new account, and we have to explicitly pass the arguments right here. You can see the value we're passing here, 1 and 2. Whenever I want to create an account object, I got to be sure what ID values have been used so far. I want to give something that's different, right? So this one tells us it's really the burden on the account user to specify unique ID. That's number one. And imagine that if you're doing some bookkeeping for the bank and you want to create, let's say, 1,000 account. In that case, maybe the account might be created at different times. That means you got to keep track of the account IDs. So you better not be wrong. You better not be causing any duplicates. The second point I want to make is this. Let's say, if me being the accountant, if somehow I pass this ID number here rather than 2, if I pass that to be 1, am I going to get any warning or error from compilation? No, because as far as compilation is concerned, as long as I'm passing some number that's integer, I'll be fine, right? So that means there's really no mechanism to really stop me from giving some ID that's going to create some clash. Go ahead, please. It will be logic error. That's exactly right, right? So you're right. So if I give some clash over here, like creating some duplicate, it's not compilation error, it's logic error. Exactly. Very good. Okay, I'm going to write it down and I'll follow up with your discussion. That is spot on, right? It's logical error. So when IDs are duplicated, it's not a compilation error. Instead, it is a logical error, which you will only realize at the runtime. So you only actually run into trouble if somehow 2 clients have the same ID. You're going to cause lots of trouble, right? So what's our goal here? So this one tells you if you only try to manage your ID manually, you'll run into these 2 drawbacks, right? As I showed you, right? 1 and 2. And our goal is this. Our goal we want to have automated, or just auto, ID generation and management. So that's something I'm going to show to you. The goal is we want to have automated ID generation and management. We want to somehow get rid of this ID as a parameter. The user of the account doesn't need to pass any ID right here. They don't need to. All they got to do is they can simply create account after an account, and somehow ID will be automatically managed by static variable, I can tell you, right? That's something we're going to see. All right, so understand this motivating example here. Really kind of appreciate if you have to do things manually without static variable, that's the best you can get. But you got lots of design flaws over here. You can easily run into issues that's logical, not really compilation error. So what I want to do, we got about 15 minutes or so. Let's say at least we can go over the static variable, okay, right here. And as I said, this code here is also on the lecture side. Please download, import it to Eclipse, and give it a try. Okay, I'll try to talk about line by line here just to see how you can understand static versus non-static. Okay, so we basically got something called counter, and we got another thing called counter tester. And I'm just using print line, just for illustration. Okay, we got 2 classes right here, and for the counter class, we got 2 variables. We got L standing for local, and we got G here standing for global. We got local and we got global. I'll explain what that really means, okay? But notice decoration here. So here for L, we got int, let me make it a bit thinner. This one here. Okay, just int L. And for the next one there, you can see we got the word static. Okay, This one here without the static. This one here with the static. All right. So what we have is we got two categories of variables right here. So L here is something called non-static variable. Non-static variable. And of course, we just call them attributes. This is something we know pretty well. And for this one here, let me just make a note right away. And this one here, of course, the G here, it is called static variables. This one here, it is called static variable. And let's now also observe something here right away. Typically, for static variable, you will try to initialize its value right away. When I declare the static variable G here, I say G should be initialized to be 0 right away. I don't do that in the constructor. So I do that right away, okay, as soon as I declare that. So this one here, you just say right here, static variable is initialized as soon as it is declared. On the other hand, you can see for the non-static variable here, it's actually only initialized in the constructor. So non-static variable is initialized in constructor. And say it again, just in case you're taking notes from me. Okay? I'm saying that for non-static variable, the way you initialize it is not to initialize as soon as you are declaring it. You simply do that, the initialization in the constructor. On the other hand, for static variable, you initialize it as soon as you actually declare that. That's the convention. Okay? So static variable initialize as soon as it's declared. Okay? That's just about kind of like a syntax I want you to identify right away. So there, we do have some patterns for you to follow. And let's see what they really mean. Okay? That's also very important. Let's start with the non-static, which we know. So for the non-static, I'll say star here. I'll put it right here. So each counter objects that we instantiate has its own copy of this local variable. So imagine that when we draw the box for each individual counter objects, each one of them has a field there called L, and they might have different values. And remember, we call that instance-specific value. That one we also know pretty well. And what about G, the static one? So that one there, static variable. So I will put a star star right here. In this case, all the counter objects share a single, or you can think about a unique copy of this G right here. So that's why we say that it's a global variable. That's really important for you to see right away, right? So when we trace the actually code using static versus non-static, that ought to be the mental model you want to have, right? So every counter object has its own copy of the L, and there's only a single copy of G, where every counter object can get access to and also change. That's something we'll see. Okay. Okay, and then let's see what's the rest of the class right here, and then we'll try to trace some code. So we got get local is simply we just say this.l, right? We're using the this keyword depending on what the context object is when we call the get local. We'll see. And also we can increment the local variable here. And we got this one here, increment global. All right. This one here is interesting, right? Currently, I simply say G++. I'm trying to increment just the G right here, okay? You might be wondering, can I say this dot G++? All right? The answer is yes, you can. You will not get any compilation error. However, you're going to get some compilation warning, which is not that fatal. If you only got warning, for your programming test, you wouldn't get any marks deducted. But I want to clarify, you shouldn't really write this.g, where g is the static variable. It simply conceptually wouldn't make sense. Okay? So let me talk about this one here. So g++ over here. Okay? So if you write this.g++, this one compiles with a warning. With a warning. Okay? In order to really get access to the global variable that's static, the convention is this. I'll give you the syntax. So accessing static variables. You will start with the class name. And then dot. The name of the static variable. So you can see we are using the dot over here, but think about the class name here is supposed to be the name of a class. Let's say in this case, counter. It's not really context objects, right? So in this example, how do we write that, right? So in this case, for example, you would say counter dot G. So this will be the accurate way to really write it. Because in order to really use a static variable, you do not really need a context object to access it. Even though you might write it, but you get a warning. That means you have some conceptual misunderstanding about how the global variable is supposed to be used. Right? That's something to clarify as well. All right, so we do have time. That's good. So let's now try to trace this together. All right. Okay, so what we got is, we got counter, we got to create two objects, right? So the way I'm going to trace is go like this. Before you even start drawing different objects for counter, you first scan through the class. Do we have any static global variable? If we do, we better initialize it right away, even before the first object is created. In this case, we do have the static global variable. So what I would do, first of all, you can think about even before this line here, I'll make it explicit. Even before this one here, I'm going to say step number 0. Okay? So step number 0, I'm just going to set aside a location in the memory. Okay? And then that one there, I'm just going to put counter here. Okay? That means this is, again, only for counter. And here, it's kind of up to you. For me, I personally just like to put the name of the static variable, but I can put a star. Maybe the star simply means it's static as opposed to non-static, right? So don't really get confused about this box here with the individual box for counter objects, right? But if you want to use a different shape, like a triangle, whatever, it's up to you, right? I just want to make it clear. So this is not an object, it's just location for the global variable. And then the initial value for this value here is for G is simply 0. Right? So step number 0 is kind of traced even before we start creating the first and second objects for a counter. Okay? And let's now trace line by line. So what I will do is, first of all, let's try with this one here. When I say counter C1 will be a new counter, right? That one's easy. So C1 stores the address of some counter objects right here. So I'm going to put counter. And now, how many attributes should I put here? 1 or 2? 1. Okay. We only put non-static attributes. That's the principle, right? So here only got L. But if you got other non-static attributes, you can also put them if you need it. Okay, so only put L. Okay, so we put L here. And then default value is simply just 0. Okay, right? Because default value is simply 0. Okay, just 0 here. And then we do the next one, counter C2. So C2 here also store the address of another counter object right here. And that one there also has one single attribute. Right? Now you can see what I really meant here. Each counter object has its own copy. C1 has its own copy. C2 has its own copy. But it's only a unique copy of static variable. Right? All right, so let's now do some very quick check. When I say C1.getLocal, right? So if I say, it's this one here, C1.getLocal. So I'm calling getLocal here. So that means this is going to be C1. What's C1.L? 0. All right. And also, if I do C2.getLocal, right? That means this will be C2. C2.local. C2.local is going to be 0. Okay, just make sure I got it right. Okay, that's good. So far, they haven't changed the value just yet. And if you try C1.g and C2.g, so these two are accessing the global variable, the static variable using context object, you will get some warning, but it's not really error, right? So C1.g and C2.g, strictly speaking, C1, there's no g right here. And C2, there's no g right here. But since we know g is a static variable, so they're really referring to just this single copy here. So you'll get the same value. But you will get some warning, okay? Just you want to avoid writing this line here. So we're going to get just the 0 and 0. And this will be the correct way of saying it. So when you say counter.g, you're really saying counter here .g is going to be 0. Okay, that's the right way to go. Okay, a few more lines, okay, just to see, make it complete. Right? So now we're actually going to do the following. Let's say we want to do the local and global change. So let me just call these ones. Let's say 1, 2, 3, 4, and 5. Okay, let's talk about these 5 lines. So for number 1, C1.increment local. So we go to the increment local here, and then the context object is C1. So this will be C1. So we say C1.L, C1.L incremented, right? So it will be from 0 to 1. And then when we do C2.increments local, right? So we are executing the same method here, but now this will be C2. So we say C2.L, C2.L is going to be incremented right here, right? So it will be from 0 to 1. Okay, so I can also say this is actually number 1, and this is number 2, right? How about number 3 here? When I say C1.increment global, so increment global here. So you can think about it, simply go here and simply increment G right here. What that does is it's simply going to increment this from 0 to 1. So that'll be the first one. So this will be 3. And then when we actually try to do C2.increment global, so we're calling this one more time, and we are still modifying the same unique copy. So that one there is going to change from 1 to 2, right? So that's number 4, right here. And another way to change it would be, you can simply say counter.g, which is referring to this variable here. You say its current value plus 1, right? So the final one. So the final one here, counter.g, this one here. So its value is simply go from 2 to 3, number 5. Right? So you can see the way things will play out, right? So we basically got local variables where each objects of the same class, they actually got their own copy. You just modify the same way as we did. But there's also a set aside unique copy there that we can manipulate. Whenever you change maybe the value from maybe 0 to 1, 1 to 2, it's going to be visible to all the objects that have been created so far. So this static variable is how we're going to actually use to manage the IDs automatically. So let me just take 30 seconds, bear with me, and then I'll let you go. Okay? So we are done with the static variable, basically, right? Just about the basic coverage. So I want you to take a look at this code fragment here before Monday, that's on the slides, and see why this one here is actually going to work. And notice that we got static global counter. We also got non-static ID, and see how these two are being used in the code. That's something you will be expected to know in the subsequent test. All right? Thank you so much. If you are going to attend a mock-up test, I'll see you in the lab. Otherwise, I'll see you next week. Okay, take care.